Atomic structure, a structure of an atom, a simplified view of an atom. An atom consists of the heavier nucleus around which the electrons are circulating in a path. An atom consists of the positively charged nucleus contains proton and neutron around which the electrons are circulating in a path. The structure of an atom compared with a cricket ball in a ground. Here, the heavier nucleus compared with the cricket ball and the path of the electron compared with the ground area. An atomic model shows an atom consists of three main subatomic particles called proton, positively charged, and electron, negatively charged, and neutron, neutral in nature. Protons and neutrons are of similar mass, that is equal to 1.67 into 10 to the power 27 kilogram, and are located in a tiny central core of the atom called nucleus. So the proton and a neutron of similar mass, that is equal to 1.67 into 10 to the power 27 kilogram. So that area is called a nucleus. Surrounding the nucleus comparatively larger distance, the electrons are moving. That region is called orbitals. So orbital is the area where the electrons are moving, is called, the path of the electron is called what? Orbital. Electrons are about 2000 times lighter than protons and neutrons. So the mass of the electron is dash. The 9.11 into 10 to the power 31 kilogram is the mass of an electron. The nucleus contains almost all the atomic mass but occupies only tiny portion of the atom's volume. So the nucleus occupy the tiny portion in atomic volume. 1 part in 10 million. That is, the portion of nucleus is 1 part in 10 million. The next one is summary of subatomic particle. Particle, symbol, mass and mass, atomic mass, unit mass, charge and location. Proton, that is H11, atomic number 1, mass number 1, the mass is 1.67 in 10 to the power 27 kilogram. The mass is 1 atomic mass unit, charge is positive. Location in the nucleus. Neutron, atomic number 0, mass number 1 and 1.67 in 10 to the power 27 kilogram. 1 atomic mass unit. Neutron is neutral in the nature and its location is present in nucleus. The next one is electron. Electron, so atomic number -1, mass number 0. Here the comparative mass is 1 part in 1835 parts by mass. Its charge is, electron charge is negative. It is present in the shells orbiting the nucleus. Here the nucleus, here it is the nucleus where proton and neutrons are present, around which electrons are circulating in a path. The three-dimensional representation is given. Next one is atomic number. What is atomic number? Atomic number is given by a symbol Z. Atomic number Z is number of proton or number of electron. Always in an atom, number of proton is equal to the number of electron. Thereby, an atom is electrically neutral in nature. Each element is uniquely identified by its atomic number. So, each element identified with its atomic number or number of electron present in it. For example, that is example given. Carbon. Carbon contains 6 proton in each nucleus. That is, atomic number of carbon is 6. Aluminium, Z is equal to 13. Z is equal to 13 means atomic number is 13. So aluminium atoms have 13 electrons in its nucleus. So atomic number is number of electrons given by aluminium, atomic number 13. Copper, atomic number Z, 29. So all copper atoms have 20 proton in its nucleus. That is atomic number 29. So atomic number 29 means the 29 protons or 29 electrons. That is atomic number of copper. Gold, atomic number, here it is given 79 proton is given. 79 proton is equal to actually gold. So gold atomic number is 79. Symbol is Arum, gold. Au 79. Hydrogen, atomic number 1, all hydrogen atom possess one proton or one electron. Hydrogen symbol H, atomic number 1, that is one electron or one proton. An electrically neutral atom will have the same number of electrons and protons. Says in a particular atom, neutral atom, it contains same number of electrons and protons. That is, atom is said to be electrically neutral in nature. So from this we can infer that the atomic number is number of electrons or number of protons, that is equal to atomic number. So generally atom is neutral in nature as the number of negatively charged electron is equal to negatively charged proton. Next one is what is mass number. Mass number is atomic number plus number of neutrons. Mass number is equal to atomic number plus number of neutron. Mass number given by the symbol A, atomic number Z, number of neutrons N. So mass number is equal to atomic number plus number of neutron. So A is the number of protons plus number of neutrons in the nucleus. That is, mass number is equal to number of protons plus number of neutrons in the nucleus, that is equal to mass number. Protons and neutrons are sometimes referred as nucleons as they are present in the nucleus. Protons and neutrons together is called as nucleon as they are in the nucleus. Here symbol silicon, atomic number 14 and mass number 29. Element name symbol, according to the symbol it is silicon. So here it is atomic number 14. So now atomic number 14 means number of electrons and number of proton is 14. Mass number is 29 and number of neutron. Number of neutron is mass number minus atomic number will give you the number of neutrons, that is 15. And carbon atomic number 12 and mass number 14. So carbon contains 12 electrons and protons and it contains 2 neutrons. So 12 plus 2, atomic number plus number of neutrons, that is equal to mass number 14. Strontium. Here atomic number is given 38, that it corresponds to the element strontium. Strontium of mass number 88 and atomic number 38. So mass number 88, that is atomic number plus number of atomic number plus number of neutrons. So atomic number 38, number of neutrons 50, the mass number is 88. So number of neutron is calculated by mass number plus minus atomic number. So atomic number plus number of neutrons will give you the mass number. So in this page what you have seen is what is atomic number and the definition of atomic number, examples are given. Here what is mass number, how to calculate the mass number or how to calculate the number of neutrons with the given mass number and atomic number. Next one is what are elements. The chemical properties of an atom determined by its atomic number. Atoms can have the number of protons from 1 to 100, that is atomic number 1 to 100. What is an element? An element is a substance which contains all atoms with the same atomic number, the same number of protons in the nucleus, that is considered to be an element. So an element is a substance which contains atom with the same atomic number. The same number of proton in the nucleus is called element. For example, elements such as oxygen, sodium, uranium, hydrogen and copper. They all contains atom with same number of protons or electrons. The arrangement of elements according to their atomic number is called periodic table. So for more than 100 elements are tabulated according to their atomic number or number of electron according to the modern periodic law. The next one is what are isotopes. Atoms with the same element have different number of neutrons. The element is the atoms with the same number of protons, but sometimes the atoms present in the element may have different number of neutrons. So the same element possessing say the elements possessing same element possess same atomic number but different mass number atom. So these are all called isotopes of the elements. So what are isotopes of the element is the element which possesses same atomic number but different mass number is called isotopes. Isotope of the element having same number of proton but different number of neutron. That is, they possess same atomic number and have different mass number is called isotopes. What are isotopes? Isotopes of the element have possessing same number of proton but different number of neutrons are called. The difference is due to the number of neutrons only. That is, possess same atomic number, different mass number. For example, now we are going to see the isotopes of hydrogen, helium and lithium. Isotopes of hydrogen are protium, deuterium and tritium. Protium atomic mass number 1 and deuterium mass number 2. Tritium the mass number is 3. The difference in the mass number is due to difference in the number of neutrons. For example, protium 1 proton and 1 electron. Deuterium 1 proton, 1 or 1 electron plus 1 neutron is present. Tritium 1 proton, 2 neutron. 2 plus 1, the mass number is 3. So they all possess same number of proton but they differed in the number of neutron. So called isotopes of hydrogen. Helium possess same number of proton but the number of neutron differed. Helium 3 mass number and helium 4 mass number. Helium 3 mass number contain 2 proton and 1 neutron. And helium 4 alpha particle contains 2 proton plus 2 neutron. 2 proton plus 2 neutron, mass number 4. They possess same atomic number but different mass number. Lithium with atomic number 6, lithium with atomic number 3, both possess atomic number 3. Here mass number 6 and mass number 7. Here the mass number 6 is due to number of neutrons 3 and mass number 7. Here the number of neutron is 4. So isotope. The isotopes are the element with the same atomic number and a different mass number. The difference in the mass number is due to difference in the number of neutrons. Isotopes of hydrogen is protium, deuterium, tritium. Isotope of helium is helium of mass number 3 and helium of mass number 4. And lithium of mass number 6 and mass number 7. All isotope arises due to the difference in the number of neutrons. So isotopes topic with example over. Here the different isotope with mass number and atomic number calculation is given. Magnesium, the different isotopes of magnesium. All magnesium atom, they possess atomic number 12. All magnesium isotope atomic number 12. They differed in their mass number due to difference in the number of neutron. Magnesium 24, magnesium 25, magnesium 26. Here the number of neutrons 12, here number of neutrons 13, number of neutrons 14. So as they differed in the number of neutron, the mass number is different, the concept called isotopes. Here the tabulation given. Magnesium atomic number, number of neutron, mass number and how it is calculated. Magnesium of mass number 24. So for this, for all types of magnesium isotope, atomic number is 12. Number of protons are 12. Number of protons or number of electrons is 12. So atomic number is 12. For the magnesium 24, the number of neutron is mass number minus atomic number. So number of neutron 12. For the magnesium 24 isotope. For magnesium 25 isotope, the mass number 24, atomic number 12, 24 minus 12 will give you the mass number minus atomic number will give you the number of neutrons 13. That is isotope magnesium 25. Magnesium 26 isotope, the mass number is 26, atomic number is 12, 26 minus 12, the number of neutron is 14. Next one is, so the magnesium exists in 3 different isotopic form as they are differed in the number of neutrons. Next one is hydrogen, the isotopic form of hydrogen. Protium, normal hydrogen, deuterium and tritium. 3 isotopic form of hydrogen. They all contain 1 proton or 1 electron. So the atomic number is 3 for 3 isotopic form of hydrogen. But they differed in the number of neutron, thereby the mass number different, the concept called isotopes. For example, normal hydrogen, the number of neutrons 0, so mass number is 1. Number of atomic number plus number of neutron 1. Normal hydrogen, mass number also 1, atomic number also 1. Deuterium, the neutron present is 1. So atomic number plus number of neutron, mass number. So mass number is 2 for deuterium. Tritium or tritium, atomic number 1, number of neutron 2, 2 plus 1, that is mass number is 3. For tritium, the mass number is 3. So same atomic number, they differed in their mass number due to difference in the number of neutron, concept called isotope. So isotopes of hydrogen. Next one is different elements with different atomic and mass number is given. We have to find out by knowing the known one, unknown one can be calculated. First one, sulfur, atomic number 16, mass number 31. Atomic number 16, mass number 31. Number of protons 16 and number of neutrons are given. So 31 means number of mass number 31, atomic number 16. 31 minus 16, number of neutrons are 15. Atomic number 16, so number of electrons are 16. Aluminium 27. For aluminium 27, the atomic number is 13. Atomic number is 13 and so thereby number of protons or number of electrons also 13. But its mass number is 27. Here it is given 27. So how many neutrons? Mass number minus atomic number. The neutrons are 14. 27 minus 14. 9. Atomic number 9 is given. For the atomic number 9, the fluorine is the element. So for the atomic number 9, number of protons or number of electrons is 9. Here the mass number is 19. So number of neutrons are mass number minus atomic number. So number of neutrons are 10. Lithium, mass number 7 and atomic number 3. Here it is given lithium. So atomic number 3, so number of electrons, number of protons are 3. Mass number 7, 7 minus 3, number of neutrons are 4. Next one is the number of protons given, number of electrons given. So atomic number is 74, belongs to tungsten. For tungsten, the isotopic mass number is 184. So number of neutron is mass number minus atomic number. The number of neutron is 110. Next one is electronic configuration of an atom. So up to that we have studied what is atomic number, what is mass number, what is isotopic form. Electronic configuration. What is electronic configuration is how the electrons are arranged in an atom around the nucleus. That is called arrangement of electron or electronic configuration. So energy level, the electron present in an orbit are called energy shells or energy level. They are named as K shell, L shell, M shell, N shell. That is equal to 1, N is equal to 1, 2, 3, 4. The electrons in each energy level is calculated by the formula 2n squared. For example, shell number and energy level is KLMN. That is K is equal to 1, 2, 3, 4. So number of electrons in each energy level is calculated by using the formula 2n squared. So by substituting the energy level 2 into 1 squared, that is 2 electrons in the first energy level. Second energy level, the n value is equal to 2, 2 into 2 power 2, 2 into 4, 8 electrons in the second energy level. M shell, the n value is equal to 3, 2 into 3 power 2, 3 into 3, 9, 2 into 9, that is 18 electrons present in the 18 electrons. It can third energy shell can accommodate 18 electrons. And fourth energy level, n is equal to 4, 2 into 4 power 2, 4 into 4, 16, 2 into 16, it is 32. So number of electrons in the last energy level is 32. So electronic arrangement in an atom, electronic configuration is arrangement of electron in an atom in a energy level or shells. Number of electron in each energy shell is calculated by the formula 2n square. Each energy level is named by k element, that is n value is equal to 1, 2, 3, 4. The number of electron each energy shell or level can be accommodated, that can be calculated by the formula 2n squared. The arrangement of electrons in an atom is represented by two level electronic configuration, 1s2, 2s2, 3s2 like that, or electron shell diagram. Electronic configuration describes how the electrons are arranged, how many electrons are arranged in each shell. Electronic configuration is 281. So the arrangement of electrons in a diagram, first level, second level, third level, that can be written. So according to their atomic number, according to the number of electrons or proton present in an atom, the elements are tabulated, that is called a periodic table. So periodic table, for example, in a particular horizontal rows are called period, and the vertical columns are called group. So in in a period, in each level, the number of electron increases. In a group, whatever be the atomic number, they all contain same number of electron in its valence shell or electronic shell. So that is arrangement of electrons in a periodic table. Here the exercises are given. Electronic shell diagram are easy to draw if you remember this rule. The proton and neutrons form the nucleus at the center. The electrons are in the electronic shell around the nucleus. The first shell can accommodate 2 electrons. The second shell can hold 8 electrons. Third shell also can hold 8 electrons. Hydrogen atom with 1 electron and 1 proton. Lithium atom can hold here 3 proton and 3 electrons. So first shell 2, the only one remaining, that is second shell. Magnesium atom, first shell 2, second 1s2, second cell. So second 1s2, second one is 1, 2, 3, 4, 5, 6. Second shell 6 electron, the remaining is only 2. So remaining only 2, the last shell 2 electron, valence electron. Name the particles that make up the atom. An atom consists of 3 subatomic particles called proton, neutron and electron. How does the electronic configuration means? Electronic configuration means arrangement of electron in each shell around the nucleus in an atom is called electronic configuration or electronic arrangement. The electronic configuration for lithium atom is Z is equal to 3, that is 1s2, 2s1, 3, 2 plus 1, 3. Carbon atom, the atomic number is 6, the electronic arrangement is 1s2, 2s2, 2p2, 2 plus 2 plus 2, 6. The neon atom, atomic number is 10, 1s2, 2s2, 2p6, 6 plus 2 plus 2, 10. State the following, what is the term means. Atomic number. Atomic number is number of electrons or number of protons are called atomic number. What is nuclear number? Nuclear number is the mass number. What is mass number actually? Nuclear number means mass number, that is number of protons or number of electrons. What is mass number? Mass number is atomic number plus number of neutrons. That is number of protons plus number of neutrons. Or it can be also said as number of electrons plus number of neutrons. The next exercise is name each of this atom, how many proton and electrons are present. Here carbon 12, mass number 12, atomic number 6. So 6 atomic number means 6 electron and 6 proton. So mass number minus atomic number, thereby 6 neutrons. Here oxygen mass number 16, atomic number 8. So 8 is number of electrons 8 and number of protons also 8. Mass number minus atomic number will give you the number of neutrons, that is 8 neutrons. Magnesium, the mass number 24, atomic number 12. So on 12 is the atomic number, 12 electrons and 12 protons. Number of neutrons calculated by mass number minus atomic number, thereby 12 neutrons. Aluminum is atomic number 13, mass number 27. 27 minus 13, that is 14 neutrons are present. 13 is the atomic number, 13 electrons and 13 protons. Here copper, atomic number 29 and mass number 64. So 29 proton and 29 electron. Mass number minus atomic number will give you the number of neutrons as 35. 5 protons. 5 protons or 5 electron, that is atomic number 5 corresponds to boron. 15 protons, that is equal to 15 electron, atomic number 15, that is equal to phosphorus. 20 protons or 20 electron, that is atomic number 20, belongs to calcium. Complete the following diagrams. Neon, mass number 20, atomic number 10. So atomic number 10 means protons and electron is 10. Neutrons are mass number minus atomic number, 20 minus 10, number of neutrons 10. So protons and neutron are 10 inside the nucleus, around which electrons are 10. Configuration 1s2, 2s2, 2p6. 6 plus 2 plus 2, 10. K shell and here 2 and L shell 8. 2 plus 8, 10. So first level K shell 2, second level L shell 6 plus 2, it is 8. Electronic configuration. Then oxygen atomic number 8 and mass number 16. So 16 minus 8, the number of neutrons are 8. Atomic number 8, so proton and electrons are 8, 8. Mass number 16, so number 16 minus 8, neutrons are 8. So 8 means the electronic arrangement, 1s2, first shell 2, second shell 4 plus 2, it is 6, K shell and L shell. So first level the 1s2, 2 electron, second shell L shell 4 plus 2, it is 6 electron. 4 plus 2, 6, 6 plus 2, 2, 4, 6. Second shell, first shell is first level 2 electron. 4 plus 2 plus 2, here 8 electrons. Electronic arrangement. Next one is what is relative atomic mass. What is relative atomic mass is when the mass of the element given in the periodic table shows actually a relative atomic mass of an element. The weight average takes the account for the abundance of the isotope. How to calculate the relative atomic mass? For example, the 100% of chlorine contains 75% of chlorine 35 isotope and 25% of chlorine 37 isotope. The chlorine 35 isotope contains 18 neutron, chlorine 37 isotope contains 20 neutron. So how to calculate the relative atomic mass of each element, each isotope present in that. Chlorine isotope of, here it contains a chlorine contains 75% of 35 isotope, 25% of 37 isotope. Average it is 35.5. How it is calculated? That is 0.75% of 35 isotope, 0.25% of 37 isotope. That is average is equal to 35.5. So the fraction is rounded to the nearby value according to the significant figures. The value once used should use the never use rounded number for this value, especially in test. Here one point is given. Here the question: naturally occurring chlorine consists of 75.8% of 35 isotope 24% percentage of chlorine 37 isotope. Calculate the relative atomic mass. Chlorine 35 isotope 75.8. Chlorine 37 isotope 24.2. So 75 percentage of 35 isotope, 24.2 percentage of 37 isotope. Here the values arrive 26.53 and 8.954. The average atomic mass is 35.484. So according to the problem given, the average atomic mass of the given mixture chlorine is 35.48. The next one is how to identify the isotope by using mass spectroscopy. So the chemistry of all elements is identical regardless of isotope. How can we tell which isotope how much different isotope are present in a sample? That is identified by using the spectroscopic method is called mass spectroscopy. In this a method called mass spectroscopy developed that allows scientists to determine how massive particles are present. It consists of first ionizing each atom present in the sample in this area. Second one is accelerating the ion towards the detector and picks up where the ion hits. Here the diagram consists of positive. Here the diagram consists of the ionizing area, and the second one is consists of the detector to pick up where it is present. Here the first point, the electron beam ionizes the sample. The positive ions are attracted over the cathode and repelled by the anode, making them to accelerate towards the cathode. The cathode has selenium, allowing some of the sample through it. The beam passes through a beam of focuser, which makes sure all are traveling in a same velocity. Then enters into a magnetic field. The field bends, deflects the beam. The amount it deflected determined by the mass of the particle, thereby separating the lighter ion from the heavier ones. Here the isotopic form of the element is passed through the inlet. Here anode and cathode is present. After the opposite to the passage of the isotope, here the electron beam is passed. In the anode and cathode area, the isotopic form get ionized, attracted by the cathode and repelled by the anode as it turns into positive ion. Depending upon the density, it moves down. After the ionization, it moves down. Where magnetic field is present, dispersed the ions according to their mass. So lighter ion falls nearer than that of the heavier one. So from this the ions are fall down. From the photographic studies, the concentration of ion present in area, the mass of the isotope is identified. Here the detector counts how many ions hit in each point along the graph like one below generated give the scientific idea of isotopic and chemical makeup of the sample. They are looking at the spectral peak. So depending upon the mass, how much percentage of ions are present, thereby the how much mass parts by mass of isotopic mass present in each one. Here one calculation is given. Calculate the relative atomic mass of the element using the answer. Identify the element. The element is strontium. Here the 38 is given. Thereby the element is the atomic number 38 and mass number 88. The strontium 86 is 10% present and strontium 87 7% is present and strontium 83% is given according to the percentage. Strontium 88 83%, strontium 87 7% and 7% and strontium 86 that is 10% is present. So according to the 86, 87 and 88, 10% 86, 7% 87, and 88 is 83%. 10, 7 and 83. According to that, 8.6, 6.9 and 73.0, the average atomic mass according to the spectral studies or graphic studies, the strontium isotope average atomic mass is 87.73. Subscribe for more videos. Thank you.